Hello and welcome students. We are doing mathematical logic and this is fourth lecture on mathematical logic. In today's lecture, we are going to start with a compound statement which is conditional statement. Before this, we have done conjunction, disjunction and negation. We are now doing conditional statement. Conditional statement is also known as implication statement. Conditional statement or implication. Implication statement. The symbol that we use for implication statement is an arrow from left to right. Arrow from left to right. So here I define what is a conditional statement. Let me first define it. If two simple statements or component statements or atomic statements P and Q, as you know students, we have symbolic representation of a statement by small letters. We can use small letters. So two simple statements P and Q are connected by group of words if then. What's happening students? There are two simple statements P and Q, and what are we doing? They are connected by group of words. If you remember earlier when you were doing conjunction, you connected P and Q by one single word and. When you were doing disjunction, you connected P and Q by one single word or. Here you are connecting P and Q by not a single word, you are connecting it by group of words, if, then. So, what did we write? We wrote, if two simple statements P and Q are connected by group of words, if, then the resulting compound statement if P then Q, then the resulting compound statement if P then Q is called a conditional statement. It is called a conditional statement or an implication statement. A conditional statement is symbolically written as, symbolically written as P implies Q. P implies Q. So I write here how it is read, and read as P implies Q. It is read as P implies Q. Let's have an example for understanding if P then Q. Students, consider I have a statement P. There is an earthquake. There is an earthquake. And Q statement is the school will be closed. The school will be closed. There is an earthquake. The school will be closed. So I'm given two statements. Now here P implies Q. As you know, students, when I write P implies Q, it is actually if P then Q. If P then Q. Okay. So how would this be framed? It would be framed as if there is an earthquake, then the school will be closed. The school will be closed. So what did I do, students? P was there is an earthquake, and Q was school will be closed. So when I used the connective if then and I wrote the compound statement, what I simply did was if I wrote P, then I wrote Q. That's it. This is what we have to do. If P, then Q. I hope you must have understood. There are few more names for a conditional statement. Few more names for a conditional statement. What does it mean? Like students, you know, a conditional statement, we call it as, like if I have P implies Q, then how do I read it? I read it as if P, then Q. Okay, this is one way I read it. Okay. The second I say P implies Q. What is the second way of saying this? The first way is, you all know, if P then Q. I read this as if P then Q. The second way of reading it, the another name is P implies Q. The third one is P is sufficient. P is sufficient for Q. P is sufficient for Q. This is third name. The fourth name is Q is necessary. Q is necessary for P. The fifth is Q follows from P. So these are few more names for the implication. We are now going to take the truth table for conditional statement. The truth table for conditional statement. So students, as you all know, a truth table gives us the truth value of a conditional statement for different possible combinations of truth values of component statement. So I shall prepare a truth table for conditional statement. I'll have P in the first column. I'll have Q in the second column, and the third column is if P then Q, that is P implies Q. So here I shall write P, this is Q, and here we have if P then Q, which is P implies Q. As you know, students, we are going to have 4 different possible combinations of truth values of P and Q. I repeat the statement once again. We are going to have 4 different possible combinations of truth values of the component statements P and Q. And what are those? Those are true, 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 false, false, true, false, false. The best way to learn this is, if you remember, I had already told you, the best way to remember all the possible combinations is you write T, T, F, F, and here you write T, F, T, F. You will get the same thing. Now students, here we have to write the truth value of if P then Q. You have to write the truth value of if P then Q. When P is true and Q is true. So remember, here for the first case, it would be true implies true. For the first case, since it is P implies Q and both are true, so it is true implies true. Remember students, if you have true implies true, then the truth value will be true. The truth value will be true. The next one you have here, P is true, Q is false. So P implies Q will be true implies false. The truth value of true implies false is false. The next you have is false implies true. So here you have F implies T, false implies true. False implies true, the truth value is true. And finally, you have false implies false, which will again have the truth value true. So let me tell you students, what is the law here? As in the earlier cases, I taught you the laws for remembering the truth value of a compound statement. Here also I shall give you the law. The law is very, very, very simple, and it is, always remember, true implying false is false, elsewhere always true. What is the law? The law says true implies false will be false. True implies false is false. Rest all true. You saw true implies true is true. False implies true is true. False implies false is also true. So the law is here. This will be the milestone. This is what going to define the law. So I write here the law for you. The truth value of P implies Q is false when P is true and Q is false. In all other cases, the truth value is true. I repeat this once again. The truth value of P implies Q is false when P is true and Q is false. See, P is true and Q is false. The truth value of P implies Q is false when P is true and Q is false. In all other cases, it is true. That is true implying false is false. True implying false is false. And all other cases, it is true. I hope you all have understood this. Let us take few problems here. So this is question based on implication compound statement. Here we have to write the given statement in symbolic form. Example 1. Write the following statements in symbolic form. So the first one here is, if triangle is equilateral, then it is equiangular. Okay, so students, see here, if this, then this. This is what the given statement is, compound statement. What am I asked to do here? I have to write this given statement in symbolic form. So see, my answer will begin as follows. I will first write the two component statements. This is one component statement and this is another component statement. I will consider them as P and Q. So I write, let P triangle is equilateral. And Q, here I take triangle is equiangular. So the symbolic form will become, as it says, if this I have taken as P, then this I have taken as Q. So I write here symbolic representation. Symbolic representation is, what is symbolic representation? P implies Q. P implies Q. I would like to say this here, students. I would like to say if suppose someone takes the first one, that is triangle is equilateral, someone takes this as Q, and triangle is equiangular, the second one is taken as Q. I'm sorry, P. If someone takes this as Q and this as P, so for them the symbolic representation be Q implies P. So whether you write P implies Q or you write Q implies P, it all depends on how you assumed. I took the first one as P. So since I take this as P and this as Q, I will write P implies Q. That's the final answer. I hope you have understood. You are given a statement, and from that statement you have to write the symbolic representation. Such questions are asked in exam, so I solved one for you. Let me take one more example, students, here. Let's have one more question, students. This question, once again, we are given the statement and we have to write this in symbolic form. So as in the previous case, here I have, if Qutub Minar is in Delhi, so this is P. The next one, it says, then Taj Mahal is in Agra. This is Q. So I take Qutub Minar is in Delhi as P and Taj Mahal is in Agra. I take this as Q. So see, what do I get? I have to write this in symbolic representation. I write, let P be Qutub Minar is in Delhi, and Q I write Taj Mahal is in Agra. So symbolic representation is, it will be P implies Q. Remember, when you give the symbolic representation, you have to give the assumption. These assumptions are very important for this to have a meaning. If you don't write the assumption, this will have no meaning. Suppose I don't write what is P, what is Q. Suppose I don't write what is P and Q. I don't write this, and I only write this thing. I only write this thing. It has no meaning. It has no meaning. So this assumption is very important.